A key point in an oxidation reduction reaction is being able to identify what's being oxidized or what's being reduced. We absolutely have to tell that so that we can figure out how the reaction is going. And honestly, it's just a way for us to identify that it's a redox reaction in the first place. So let's focus on being able to identify what your oxidizing agent is, what your reducing agent is, and how many electrons are actually being transferred. Because we need to be able to do that before the next module when we start actually balancing reactions. Because balancing redox reactions is not quite the same as balancing a regular reaction. We have to follow a set of rules so that we get to the correct place. Redox reactions themselves. A little bit of review here again. A redox reaction is where a reaction in which oxidation and reduction both occur. We call these reactions redox. So we're looking at the reduction portion and the oxidation portion. Overall, we just call them redox reactions. Or sometimes oxidation reduction reactions, because oxidation cannot occur without reduction. Remember, oxidation is the loss of electrons. Reduction is the gain of electrons. If a species is losing electrons, those electrons have to go somewhere. If a species is gaining electrons, those species have to come from somewhere. We can't just lose things or gain things without them going somewhere or coming from somewhere. Law of conservation of mass still exists. We cannot create nor destroy things just because we don't want to have to deal with it in a balanced equation, okay? We have to identify where it's coming from, where it's going. So one substance cannot be oxidized unless another substance is reduced. The easiest way to approach redox reactions is to determine the oxidation state or oxidation number of every element in the reaction. Then we can identify where they're coming and where they're going. So, previous definition of oxidation is losing electrons. A more useful definition of oxidation, though, is an increase in oxidation number or oxidation state. The previous definition of reduction is gaining electrons. A more useful definition of reduction is a decrease in your oxidation number or oxidation state. And again, as a reminder, your oxidizing agent is something that is reduced itself. It's oxidizing something else. A reducing agent is a substance that has oxidized itself. It is reducing something else. It's acting as an agent. It's letting it happen to something else. In order to be an oxidizing agent, a substance has to have an element in one of its higher oxidation states because it needs to be able to gain electrons. In order to be a reducing agent, a substance must contain an element in one of its lower oxidation states because it needs to be able to lose electrons. And then I have this note here saying what differentiates the common definitions of oxidation reduction used in general chemistry and organic chemistry. I have that in here to remind you guys what, because if you go on to organic, you're going to see it slightly differently. And so I want to put this in here so that I don't forget to tell you guys. So I'm going to go ahead and just kind of move the screen over here and give myself some space to write. So let's go ahead. I want you to make this box in your notes. Okay, and we're going to write oxidation and reduction. We're going to specify for general chemistry and for organic chemistry. Oxidation is the decrease in number of electrons or increase in oxidation number. Reduction is the increase in electrons, so I gained electrons, or I reduced my oxidation number. This is always true. This is the fundamental definition of redox. What you're going to find when you get to organic, though, in organic chemistry, they say if you have increased your oxygen content or decreased your hydrogen content, you have oxidized your species. If you have decreased the oxygen content or increased the hydrogen content, you have reduced your species. So it's just a different way of thinking about it, because in organic, you're dealing with different, you're dealing with a lot of carbon, a lot of oxygen, and hydrogen. In organic, when they say you've oxidized it, you've increased the oxygen content in the sample. If you've reduced it, you've decreased the oxygen content. It's not incorrect, but I just want you to identify when you get to organic and they start saying it and you're like, but that's not what I learned in Gen Chem. That's why. We're using in Gen Chem is your fundamental definition of it, but in OChem, they're using an applied definition of it. So let's work an example. Determine the oxidation number of each element in this reaction. We've got magnesium reacting with hydrochloric acid to form magnesium chloride and hydrogen gas. Now, note that the magnesium here is solid magnesium. The hydrochloric acid, it is aqueous, so therefore I know it's your acid. It's not just HCl gas, it's hydrochloric acid. It's actually the acidic form of it. Magnesium chloride is a aqueous species, so really what's happening in solution here is this is really Mg2 plus and 2 Cl minuses, right? This is really H plus, 2 H pluses, and 2 Cl minuses. So chlorine here, the chloride ion is a spectator. I could even rewrite this reaction as Mg solid plus 2H plus, giving me Mg2 plus H2 gas, where these are both aqueous species, as the net ionic. And I'll talk about why I do that in a sec, because it might help us just identify a little bit of what's going on. But I want to know what's oxidized, what's reduced, what's my oxidizing agent, what's my reducing agent. So the first thing I'm going to do is I'm going to go through here and I'm going to assign oxidation numbers of each species in the reaction. If you want to write down what I just wrote down, go ahead and do it. Pause the video because I'm going to erase all this stuff quick. I'm not going to erase that reaction. I'm going to show you how that reaction just kind of quickly shows me what's happening in the system. But first, I want to assign oxidation numbers of each element. I have magnesium solid. That is magnesium in its most stable form. It has an oxidation state of 0. There's no charge to it. It's just magnesium listed. It has an oxidation state of 0. HCl, hydrochloric acid. Chlorine is the more electronegative element of this binary acid. So chlorine is going to be a -1 charge, and the hydrogen is going to be a +1 charge. Again, hydrogen cannot go greater than +1. It's either +1 or 0. It only has 1 electron. Magnesium chloride. Chloride, again, more electronegative, -1. MgCl2 means I have 2 chlorines, each at -1, overall -2 charge. 1 magnesium has to do something to add up to 0. It must be +2 here. And hydrogen gas. Hydrogen is one of our diatomics. When I have H2 gas, it's its most stable form, so that will be 0 as well. The reason I like the net ionic equation is it actually kind of shows me this stuff a little bit faster. The spectator here, the chloride spectator, isn't changing at all, right? It's saying -1 the whole time. The net ionic is a quick way for me to identify what's actually being oxidized and reduced. I can see the magnesium here is 0. The magnesium here is +2. Hydrogen here is +1. Hydrogen here is 0. So sometimes if you get kind of bogged out by the equation, sometimes writing the net, if you can identify the net ionic correctly, it can actually be a faster way to find what's being oxidized, what's being reduced. So I'm going to erase the net ionic, but if you see that better, please write that down quick. Now I'm going to look here. I'm going to say, okay, magnesium went from 0 to +2. And the hydrogen went from +1 to 0. Magnesium (0 to +2). It lost 2 electrons. Because it lost electrons, it has been oxidized. Magnesium has been oxidized. When I look at the hydrogen, hydrogen went from +1 to 0. It gained 1 electron. It has been reduced. Now, overall, 2 electrons were transferred, right? The magnesium lost 2 electrons. Those 2 electrons have to go somewhere. We did lose 2 electrons, but I had 2 H pluses reduced to H2. So each hydrogen ion took 1 electron. Which element is reduced? H plus. Hydrogen is not reduced. Hydrogen itself, I just say hydrogen, it's implying it's neutral. The hydrogen ion was reduced. What is the oxidizing agent? Oxidizing agent is reduced itself. It oxidizes something else. So your hydrogen ion, put that plus sign there just to emphasize it, is your oxidizing agent. And the magnesium is your reducing agent, because it itself was oxidized and it caused something else to be reduced. Magnesium gave up its electrons to hydrogen, allowing the hydrogen ion to be reduced. Make sure you're comfortable with this, because you have to be comfortable with this before the next module when you start looking at actually balancing equations.